Yeah, now we are taking up the periodic properties. So we have various periodic properties that an element can show. So the first property we are taking into the consideration is atomic radii. So what does atomic radii means? Atomic radii actually means, see, we have an atom and we assume that atom to be a sphere. So the distance from the center of the nucleus to the outermost shell is called as atomic radii. So that means atomic radii is the distance from the center of the nucleus to an outermost shell. So how this property varies along group and period, as I've told you when we were doing the modern periodic law, the modern periodic table. So I told you there were 18 groups and 7 periods. So we need to know the how properties varies along group and how properties vary along period. So first property is atomic radii. So for the sake of convenience, I am taking an example. So let us consider the first group, that is the alkali metal group. See, we know it consists of hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. You all know this now. So we are taking into consideration that how atomic radii vary when we move along the group. When we move down the group, how atomic radii vary. Like what similarity do the group elements have and what dissimilarity they have when they are compared to the other group. So first we are taking into consideration, the first step we have to write the atomic numbers. So atomic number of lithium is 3, we know, and for the sodium it is 11, and for the potassium it is 19, and for rubidium it is 37, for cesium it is 55, and for francium we have 87. But we will be excluding francium because francium is a radioactive element. All elements which are placed below in the last row are radioactive elements. That means they have unstable nuclei. So all those properties which we are studying will not be taking into consideration for the radioactive elements because they show different properties. So we will be taking an example only this thing before the last one, means till the 6th group we will be taking 6th element of the 6th period, we can say. So I am taking into consideration only the 6 elements because last one is the francium, and francium show radioactive properties. So after writing the atomic numbers, I am writing the electronic configuration. So just look at the board carefully so that you should know that what similarity or what you can have an idea that how the size varies. But for 37 and 55, you won't be able to write electronic configuration because there is a different method of writing the configuration. As you will go in higher class in +1, you will learn that the writing of electronic configuration is something different you have done till now. So just write the electronic configuration till the 20 atomic number because before that, after that, you don't know how to write it. So just for your level, write it till potassium. So what can you see on the board? See, lithium, that means it consists of 2 shells, right? K and L. For sodium it is 3 shells, K, L, M. For potassium it is 4 shells, K, L, M and N. So what do you think that out of lithium, sodium and potassium, which will be bigger? So you can easily see it contains only 2 shells, means 2 electron clouds, and it contains 3. It contained 4. So likewise, as we are moving down the group, every time a new shell is being added. What you see? That every time a new shell is added. So what happens when new shell is added? Then what do you think that probably has happened, that the size goes on increasing as we are moving down the group? So again I am repeating, as we are moving down the group, every time you can see a new shell is being added, due to which the nuclear charge, what is nuclear charge? It is actually the attraction of electron that it is experiencing from the nucleus. Nuclear charge is the force with which the nucleus exert on the outermost shell electrons, and it is always an attractive force. So whenever a new shell is being added, then nuclear charge decreases. This leads to increase in size. That means attraction is not so strong, therefore the electrons are not so closer to the nucleus, they are experiencing the less force of attraction, so that's why size increase. So how you are going to write an answer if you will get that how the size increase along the group? You will be writing that you will write the atomic number, configuration, then you will be writing as we move down the group, every time a new shell is being added, that you can see it has 2 shells, it has got 3 shells, it has got 4 shells, and likewise it happens for rubidium and for cesium. By one shell increases as we move down each step. So every time a new shell is being added, due to which nuclear charge decreases and which leads to increase in the atomic size. That means the size increases as we move down the group. But now we are considering a period. So let us take an example of second period. So second period consists of this thing, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So I am writing the electronic configuration for them. So it is 2,1, it is 2,2, it is 2,3, it is 2,4, it is 2,5, it is 2,6, it is 2,7 and it is 2,8. So now do you have an idea about the atomic size? What do you think, that the size may increase or decrease as we move along the period? So what you get to see by looking at the electronic configuration? We see every time the number of shell remains same. Every time the number of shell remains same. When I am taking example of second period, so all these elements of the second period, they have only 2 shells, only 2 shells. But what change do you observe when you move from one step to another? We see that every time when we move in a period, that means every time a new electron is added to the same shell. There is no change in the number of shell, the shell is always the L, but every time a new electron is added. See, when we move from lithium to beryllium, there is increase in 1 electron. Similarly, when we move from beryllium to boron, there is increase in 1 electron, and similarly it happens as we move along the period. So every time when we move in a period, we see a new electron is added to the same shell. Then what happens when new electron is added? That means the nuclear charge, the attraction which they are experiencing by the nucleus increase, and whenever the attraction increase, that means the shell, the outer shell will contract. So that means the size decrease. So this is how the first atomic property, atomic radii vary along group and period. That is, along group it always increases. No matter it is a metallic group or a non-metallic group, it always increases down the group, because when you will be writing the electronic configuration for the different groups, you will get to see that every time when we are moving down, so at each step there is an increase of 1 shell, and whenever the new shell is added, the nuclear charge decrease, that means the force of attraction decrease. So the outermost shell move farther from the nucleus, that is why the size increase. And if I take an example of period, the size always decrease when we move in a period, but still we get to see certain exceptions also that we will discuss later on. So I am taking an example of second period. I have written the elements accordingly with the electronic configuration, and as we move along the period, the elements of the period, we see that every time a new electron is added to the same shell, at each step there is an increase in 1 electron in outermost shell. Then what happens? Due to this, the nuclear charge increase, leading to decrease in the atomic size. That means the outermost shell is getting contracted, and the size, the atom just get condensed. So that is why the size decrease. So that means in the periodic table, the elements which are present in the group 1 are biggest of the all, biggest in their own period. Like if I am taking example of second period, so out of this period, which is going to be biggest? This is going to be biggest. And similarly, for third period, sodium is going to be biggest. And if we talk about the smallest one, then they are not the 18 group, because 18 group elements actually are noble gases. Noble gases have the, you can say, the certain kind of special force in them called as van der Waals force, and which is a weak force. This van der Waals force, I repeat, the noble gases have a certain kind of force called van der Waals force, which is a weak force. So this, that is, and moreover we know they have stable electronic configuration, their octet is complete. So all those the properties which we are following extend only up to the 17th group, that is up to the halogens. So the biggest group is alkali group and the smallest group is the halogen group. So do not include noble gases in your this thing. Whenever you are making any property, when you are considering any property, because they show an exceptional case. And similarly the 7th group elements, the 7th period also show an exceptional case as they are radioactive. So just keep in mind all those properties which I am telling you are just applicable to other members, not to the 18th group and not to the elements of the 7th period. So this is how you are going to explain the first property, atomic radii. I think you must have understood it well now. So we are taking into consideration the second property, that is the ionization energy. We can also call the ionization energy as ionization enthalpy. Just keep in mind that enthalpy and energy both are same. Whether you use word enthalpy or it is energy, it is one and the same thing. The difference is there, but you will get to know in higher class. So up to your level, you can easily use the word enthalpy or energy as one word. So second property that we are taking into consideration is ionization energy. So what is this energy? Ionization energy is actually an energy. You know there is a nucleus, we know there are shells, and in shells electrons are present. So for example, the outermost shell, the example I am taking, the outermost shell is L and it contains 1 electron. So that means 2 electron is there in the K shell and 1 electron is there. So it comes out to be 3 atomic number. That means the atomic model this I have drawn is for lithium. So likewise you can draw a model for anyone. So what does this property actually means? Ionization energy means that we know that the configuration of lithium, the example we took is 2-1. That means to acquire the noble gas configuration, it has to lose its valence shell electron, that is the 1 electron. It has to lose this electron, right? So how it is going to lose this electron? And we have already studied in the Bohr model, the electron neither lose energy nor gain energy when it is present in its own orbit, because the orbits are called as energy levels because they have fixed amount of energy, right? I think you remember it. So likewise it is applicable in this case also. That means lithium need to lose 1 electron, but it cannot lose on its own. It requires a certain energy from outside to lose this electron, and this energy is called as ionization energy. So I am again repeating, ionization energy is the amount of energy which will be giving it from outside, right? This energy will be giving from an external source. So this energy will be accepted by this electron, and when it accepts this energy, it will get ejected. So that means it is ionization energy. I repeat, amount of energy which is required. Required means we have to supply it from outside, right? The amount of energy which is required to remove more the loosely bound electron from outermost shell of an atom. Any electron that enters, it enters into the valence shell, that means the outermost shell. Any electron which is lost, it happens through the through the valence shell. So any electron is entering or going, it is done in the valence shell. Inner shells do not participate at all. So everything in bond formation, the shell which is involved is valence shell. So just keep in mind, the electron which is coming or electron which the atom is losing is the outermost electron. Everything is happening on the outermost shell. Right. So ionization energy is the amount of energy which we are giving, right? See, we are giving it from any external source to eject this electron. This electron will pick up this energy and will get ejected, right? So this is called as ionization energy. Now we are looking for the factors on which ionization energy depends and how it varies along group and period. So similarly, I am taking an example of group. So along group, ionization energy actually decreases. Now we are looking like what are the factors which leads to decrease in this ionization energy. So again, I am taking an example of first group. So write lithium, sodium, potassium, rubidium, cesium, francium. I am not taking because it is a radioactive element. So again, I am writing the configuration as you can see. I am writing only till potassium because beyond it you will be learning how to write the configuration in the 11th class. So I have written this electronic configuration. So just see, as we are moving down, I have told you that ionization energy decrease as you move down the group, right? Now how it is getting decreased? So same as we did in atomic radii, every time when we are moving, what happens? New shell is being added. You can see 2 shells, 3 shells, 4 shells. So that means new shell is added. What happens due to this? Nuclear charge decrease, means the outermost electron is experiencing less force of attraction by nucleus, right? So that means if the nucleus is here, the outermost shell electron is here. It is getting expanded, you can say. So if when the nuclear charge decrease, that means the nucleus has no control, less control you can say on its valence shell electron. So that means it can be easily removed. So that means the energy which will be required to remove that electron will obviously low. So that means every time when we move down, the size the shell increase, nuclear charge decrease, that means the force of attraction which an electron is experiencing from the nucleus is less. So that obviously it means when it is experiencing the less force of attraction, that means less energy is required from outside to remove that electron. So that means ionization energy decrease as we move down the group. Now taking into consideration similarly what happens a long period. So I am taking the same example, I am taking the second period. So lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. I am not writing the noble gas configuration, but noble gases, but still okay, you can write it also, it is not a big deal. So I am writing the configuration. Again, you know how to write this configuration. So I am writing this configuration in this way. Now what happens? When we are moving along period, as we did in atomic radii, as we are moving along period, what happens? A new electron is added in same shell, due to which nuclear charge increase and size decrease. This we already did in this atomic radii. Now we are just looking that how ionization energy varies with this factor. So again I am just explaining you, just listen to it carefully. New electron is added, that means nuclear charge increase. When there is an increase in nuclear charge, that means nucleus is attracting that the outermost electrons with a greater force, right? So when there is the greater force of attraction, so you tell me that energy required to remove that electron will be more or less? Obviously it is going to be more, because the electron has to overcome that force of attraction to get removed. So that means ionization energy increase as we move along period, right? And if we take an example of noble gas, so that means lithium has the less ionization energy, it has more, and it goes on increasing. So neon also has the higher ionization energy. Now the question must be striking your mind that out of fluorine and neon, ma'am, you said that the fluorine is the smallest one and neon is not the smallest one, because it has a special van der Waals force which is a weak force in noble gases. But still the ionization energy of neon is greater than fluorine. You know what the reason behind? The reason behind that it has already fulfilled its octet. It has the noble gas configuration, stable configuration. That means there is an exact balance between the electrons and the nuclear charge. So that means the greater energy is required to disturb this electronic configuration, to disturb the stability of neon. That is why the noble gas are less, the ionization energy is maximum in case of noble gases and they are maximum stable, right? So we are taking into consideration the third property, that is electron affinity. Electron affinity can also be called as electron gain enthalpy. So whatever word you can use for it, it means one and the same. So we are going to study the third property, that is the electron gain enthalpy, or you can say electron affinity. So we did in the previous property that whenever we want to remove an electron, we have to supply energy from outside, right? And that energy is called as ionization energy. We did in previous property. Now the question comes, what is electron gain enthalpy actually? Electron gain enthalpy means whenever you need to add an electron, because we can easily remove an electron and also we can add an electron. So to remove an electron, we have to supply energy from outside. But whenever we want to add an electron, energy is released by an atom. So that energy which is released when an electron is added to the outermost shell of an atom when it is in gaseous state is called as electron gain enthalpy. So I am just repeating again, keep in mind, to remove an electron you have to supply energy from outside, and that is ionization energy, right? And when you want to add an electron, energy is released from the atom, and that energy is called as electron gain enthalpy. So that means to remove an electron we have to supply the energy in the form of ionization energy. So that means the energy is plus E. Plus E means positive, it has to be supplied, right? But when we are adding an electron, energy is released from the atom, that means minus. That means energy is released. Whenever something is happening into the system, we take it as positive sign, and whenever something is the system is losing, we take it as negative. So that is why I have written plus E and minus E. Moreover, you can also write it as plus delta E, because the correct form to write is delta. Delta means change. So that means the change in internal energy, how the change in energy, how the energy has changed. Plus means you have given it, and minus delta E means change in energy, how the energy is being given by the atom. So you should be little bit familiar with the sign conventions, otherwise you will be using it in higher class, but still I was taking an example, so I have told you what does this plus and E means. Exo and endothermic, what is it exactly? So exothermic means whenever the energy is released, endothermic when you are giving it. So to remove an electron we have to supply it, and that energy is called ionization energy. And when you add an electron, energy is released in the form electron gain enthalpy. So that now coming to the point that how electron gain enthalpy varies along group and period. So again I am taking the example of group. So again I am taking the example of first group. I am writing the configuration. Again you know how to write it now. So what happens to the electron gain enthalpy? It decreases. It has the same effect as the ionization energy has, the same effect. Because the ionization energy and electron gain enthalpy both depend upon the nuclear charge. So whenever there is a decrease in nuclear charge, so obviously the outermost shell electron is experiencing the less force of attraction. So that means it has got the less force it is experiencing from the nucleus. So if anything has less force, so that means it is easy to extract it. So similarly, because it is experiencing the less force, so that means the energy will be given out will be less, and even if you want to remove the electron, then energy absorbed will also be less. So similarly, as we move down the group, what happens? Again you have to write the same thing, because we have to explain the answer stepwise. So as we are moving down the group, what happened? The number of shell increase. What happens then? Nuclear charge decrease, size increase. So that nuclear charge decrease means less force of attraction. So that means even the electron gain enthalpy is going to be less, means less energy is released when an electron is added to the shell. Similarly, it is for period. As we move along the period, the same example you can take. Every time when we are moving, a new shell, new electron is added to the same shell, due to which nuclear charge increase means force of attraction for the outermost shell electron increase. Therefore, the size decrease. So that means the electron gain enthalpy will obviously going to be maximum, and it is maximum for the case of halogens because they have such a small size. So whenever you add an electron, the tremendous energy is released, right? So this is the third property, the periodic property, that is the electron gain enthalpy. Next we are considering the character. Character, when we talk about character in chemistry, it means metallic character and it means non-metallic character. Metallic means tendency to lose electron, and non-metallic means tendency to gain electron. As we have done in the modern periodic table, I told you that at extreme left there are metals and on extreme right there are non-metals. So as the size increase, what happens as we move down? See, you have to keep in mind that the metals always lose electron, right? And the one who lose easily is more metallic. So that means the one who will lose easily, that means it is going to have the less ionization energy because the size must be increasing. So that means as we are moving down the group in the metallic group,